two cones are submerged into this conical vessel, bigger conical vessel. And once they are submerged, a certain volume of water flows out. Okay, certain volume of water, it flows out of this. Okay, what is the volume of water that flows out? It is said that one third the volume of the this conical vessel, one third the volume of this bigger cone, this water, it actually flows out of this conical vessel. Okay, now you already know that if one third of the volume of this one third of the volume of this cone, it flows out, then whatever water that flows out of this conical vessel, whatever volume of water that flows out, it must be equal to the volume of the two cones, right? These two cones, that have been submerged, the volume of these two cones must be equal to the volume of water that is flowing out, right? So we say the question here is, find the volume of the, what is the volume of each of the cones submerged, that is what is the volume of each of the two smaller cones that are submerged. So I say let the volume of the two smaller cones be V. Okay, so what is the total volume of the two cones? You must read the problem very carefully in mensuration, otherwise it will be very difficult. You have to read it very carefully. So 2V, this is the volume of water that this is the total volume of the two cones that have been submerged. Now let us calculate the volume of the cone here, the conical vessel. So volume of the conical vessel. One third pi r square each. One third pi. The diameter is given to be 16.8, so the radius will be 16.8 by 2. One third pi r square into height is given to be 20. This is the volume of the conical vessel. So you can cancel here. You get 8.4. So you get one third pi into 8.4 into 8.4 into 20. This is the volume of the conical vessel. Now, if you read the problem carefully, it is said that one third of the volume of this conical vessel flows out. So how much is the volume of water that flows out? Volume of water, let's say displaced, is one third of the total volume of the cone. One third of, and what is the one third into, what is the total volume here? One third pi into 8.4 into 8.4 into 20. This is the total volume of water that is displaced if the when the two cones are submerged. Let us calculate what is the volume of the water that is displaced here. So one third into one third, put the value of pi as 22 by 7. Now you can cancel here. Okay, and this also you can cancel with 3. So 1.2 will cancel with 3.4 times, and again this 3 will cancel with 8.4. This will cancel 2.8 times. So what are you getting at last? You are getting 22 into 0.4 into 2.8 into 20. This is the volume of water that is displaced, centimeter cube. Now, volume of water displaced must be equal to the volume of the two cones. Volume, in fact, let's say total volume of the two cones must be equal to volume of displaced water. Okay, so that means Total volume was 2V, and volume of water that was displaced was 22 into 0.4 into 2.8 into 20. So from here you can calculate the volume. Therefore, what is V? V here is 22 into 0.4 into 2.8 into 20 whole divided by 2. You cancel this 2 with this 20. So what you get here is 22 into 0.4 into now 2.8 and 10. If you multiply these two together, you simply get 28. Okay, and therefore this becomes 22 into 4 by 10 into 28. Okay, now if you, because you have 10 in the denominator, okay, if you multiply everything, you will get 2464 divided by 10, and this is 246 divided 0.4 centimeter cube. So each of the cones that was submerged had volume 246.4, and that was your question. Okay, so this is your number 17. Let us look at number 18. Number 18 is in fact an important kind of a problem. It is actually purely a problem where where a, a solid is converted into another solid. Okay, let's see what the problem is. Yes, number 18, if you read the problem, it states a solid metallic cylinder of radius 14 centimeter. So you have a metallic cylinder, its radius is 14 centimeter and height is 12 centimeter, that is given to you. Now this cylinder is melted and recast into small cubes of edge 2 centimeter. Now this is melted, whatever the material is, whether it is made of iron or tin or whatever, that cylinder of given radius and given height, this is melted. And after melting, what is formed here is a small cubes. Small cubes are formed of this cylinder whose edges are 2 centimeters. So you have a cylinder, solid cylinder. This is converted into small cubes. I don't know how many. That is what the question is. How many cubes can you make out of this? Okay. So they are made into small cubes. I don't know how many. Let's say X cubes are made. And what are the dimensions of the cylinder given? The dimension of the cylinder radius is given to be 14 centimeters. This is given to be 14 centimeters. And the height of this cylinder is given to be 12 centimeters. This is exactly the kind of problem that we have discussed back in your class 9, when a cuboid was getting converted into cubes. So what should we do here? I say let the number of cubes that can be recast. What is the language that you use here? Made. Let X cubes be made from the solid cylinder. Okay, now if I'm making X cubes, and what is the edge of each of these cubes? It is 2 centimeters. All this is 2 centimeters. All this is 2 centimeters. Okay, of this cube. So volume of the cylinder must be equal to volume of X number of cubes that we are making. So therefore, we first find out the volume of the cylinder here. So volume of the cylinder, because no material is getting wasted, therefore volume of the cylinder must be equal to volume of the X cubes that you are making. Any wastage given here? Anything that is wasted? No. So we must assume that no material is wasted. The entire material that we get after melting the cylinder is being used to make it into cubes. So volume of the cylinder let's say material of the cylinder is pi r square. What is the radius here? Radius here is 14 h to 12. Okay, so this is pi into 14 into 14 into 12. Let us keep it that way. We'll see later if required, we'll multiply and put the value of pi. So this is centimeter cube. If x cubes are made, what is the volume of one cube? Volume of each cube. Volume of each cube. Each cube has edge 2 centimeter. So volume of each cube is 2 cube. So volume of x cube is must be how much? X into 2 cube, right? Centimeter cube. This is the volume of x cubes. So now the volume of this cylinder that we have got, because no material is wasted, volume of the cylinder must be equal to volume of x number of cubes that you are making. So therefore, according to a problem, volume of the material of the cylinder is equal to volume of x cubes. So now put the values. What is the volume of the cylinder here? Pi into 14 into 14 into 12. And volume of x cubes is x into 2 cube. Now you can put the value of pi and calculate the value of x from this equation. That means x is okay. So this is now you cancel. This 2 will cancel here and this will cancel here. So how many cubes you're able to make? Here you're able to make 11 into 14 into 6 number of cubes. And this comes to how much? So will this cancel any further? This is 14 by 2. I'm working with 14. Okay. What was the diameter? Was the diameter given or okay, radius was given? Then this is okay. This is okay. So how many cubes can you make? You can make 924 cubes. 924 cubes you can make out of this cylinder. Okay. So that's your solution to this problem. Let us do another one and the last problem and an important problem also. We have done this kind of a problem earlier also, and this problem would be number 28. Try to understand the problem. This is not an easy one. If spheres has been removed from your syllabus, quite likely that this kind of problem they can give. The question here reads,
Sir,
yes.
now
Tell me.
what is removed from the syllabus?
Spheres. So
Sir,
number
what is removed from the syllabus?
spheres.
Okay, sir.
Number 28. Water is flowing at the rate of 15 km per hour through a pipe of diameter 14 centimeter. This is what the problem reads. Into a cuboidal pond, which is 50-meter long and 44-meter wide. In what time will the level of water in the pond rise by 21 centimeters? So what is the problem here? You have a pipe here, cylindrical pipe. And from this cylindrical pipe, it is flowing into a cuboidal pond. Let us say this kind of a pond. So water is flowing from this pipe into this pond. And the question here is, in how much time will the water level say rise to 21 centimeter here in this pond? What else is given? It is given that water is flowing at the rate of 15 kilometer per hour. Now, what does this mean? This is very crucial information that is given. That is, water is flowing at the rate of 15 kilometer per hour. So water, this a column you have here, and you have another column here. Water is traveling at the rate of 15 kilometer in 1 hour. So say this length is 15 kilometer. How much time is it taking to travel this distance? It is taking 1 hour to travel 15 kilometers. Okay. The question here is, okay, and diameter of the pipe is also given. So diameter of the pipe is given to be 14 centimeters. Okay. The question here is, how much time will it take for the water level to be 21 centimeters in this cuboidal pond? Okay. So first of all, I will calculate how much water is flowing through this pipe in 1 hour. Okay. Now first, if you see all the measurements, this measurement here of the cuboidal pond is given in centimeters. Okay. Even in fact, the diameter of this pipe is also given in centimeters, but the speed of water is given in kilometers. So let us convert this speed to centimeters. So 15 kilometer per hour is 15. If we change kilometer to meters, it is 15 into 1000 meters per hour. And if we change meters to centimeter, it is 15 into 1000 into 100 centimeters per hour. So this is 15 into 1000 into 100 centimeter, this distance. Okay. And how much time is it taking to flow this distance? 1 hour. Okay. So what is the volume of water that is flowing in 1 hour? This volume is flowing in 1 hour. This volume, this column here, this much volume of water is flowing in 1 hour. So what is the volume of water flowing in 1 hour? Through the pipe in 1 hour is equal to pi r square. What is the radius here? Diameter is given to be 14 of the cylindrical pipe. So 14 by 2 is your radius, pi r square, into height. And what is the height of this? Height of this is this 15 kilometer is the height of this. And 15 kilometer we are converted into centimeters. So let us write it in centimeters, because all units we are converting to centimeters. This is the volume that is flowing in centimeter cube. This is the volume of water flowing in 1 hour. Okay. So if we just simplify this a little, you get pi into 7, 7 square. So it becomes 7 into 7 into 15. This much centimeter cube. Also, you see that 7 can be cancelled. You put the value of pi also. This to cancel. So what you get here is volume of water flowing in 1 hour is this. Okay. Now, so the story of the cylindrical pipe is finished. Now we come to the story of the cuboidal pond. What is the volume of water in the pond? How much is the water is needed in the pond? 21 centimeter height water is needed in the pond. And what are the other dimensions of the pond given? The other dimensions of the pond given are 50-meter wide. So this is your 50-meter wide and 44-meter long. Say here 44-meter. So what is the volume of water in this? If the height of water is 21 centimeter, what is the volume of water in the pond? Volume of water in the pond is equal to length into breadth into height. Now length is given in length and breadth both are given in meters. Length is given to be 50 meters. So you convert to centimeters. Breadth is also given in meters. Breadth is given to be 44. Just put it, convert to centimeters. And only height is 21 centimeter. So you put it as 21. So this is the volume of water in the pond after the water has flown from the pipe into the pond. Now this much volume of water is flowing in 1 hour. The question is how much time will it take to reach to a height of 21 centimeter in the pond? Okay. So if this much volume of water is flowing in 1 hour, then how much will this much volume of water take to flow? That will be our required time. So 22 into 7 into 15 into 1000 into 100 centimeter cube of water flows in 1 hour. Therefore, 1 centimeter cube of water flows in 1 divided by 22 by 7 into 15 into 1000 into 100. This much hour. Therefore, what is the volume of water you need to flow from the cylindrical pipe? This much volume. So therefore, 50 into 100 into 44 into 100 into 21 centimeter cube of water flows in how much time? 50 into 100 into 44 into 100 into 21 divided by 22 into 7 into 15 into 1000 into 100. This much. So how much should it come to? This cancels off. Okay, this 22 cancels with this. Okay, this 7 cancels with this. This again 2 zeros cancel here. 1 0 cancels here. 5 cancels with this. 3 times 3 cancels here. So 2 hours. That is your answer. So in 2 hours, you get a height of 21 centimeter. In 2 hours, you get a height of 21 centimeter in this cuboidal pond. Okay. So that is the solution to your question. This was in fact a little tricky problem. Okay, please go through this problem.